Hi everyone, this is Girish. I am from CSC department, currently pursuing Sri Venkateswara College of Engineering. Today we are going to discuss about introduction to 2D and 3D transformation. Transformations are the fundamentals building blocks of computer graphics and graphics animations. They allow us to manipulate the size, position, and the orientation of 2D, 3D objects, enabling us to create dynamic and visualized compelling scenes. In this presentation, we will be exploring the key concepts and practical applications of 2D, 3D transformations, from the basic principles of translation, rotation, and rotation scaling to more advanced techniques that unlock the full potential of digital art and design. Now, let us see some 2D transformations. Translation. 2D translation involves moving an object along the x and y axis without changing its size or orientation. This is often used to position elements on the canvas or reposition objects within the scene. And coming to the rotation, 2D rotation allows you to spin an object around a fixed point, which can be useful for creating dynamic effects such as making a character turn or a wheel spin. And coming to the scaling, 2D scaling enables you to resize an object, making it larger or smaller. This can be used to create the illusion of depth and emphasize or de-emphasize elements and adjust the overall composition of a object. Now let us see about translation. There are three types of translations. One is initial position, horizontal translation, and vertical translation. Coming to the initial position, the object started at the specific position on the 2D plane. And coming to the horizontal translation, the object moves along the x-axis, keeping its y-axis y-coordinate constant. And coming to the vertical translation, the object moves along the y-axis, keeping the x-coordinate constant. Now let us see about the rotation. Rotation have three types: initial orientation, counterclockwise rotation, clockwise rotation. Coming to the initial orientation, the object start in a specific orientation, typically aligned with a coordinate axis. Coming to the counterclockwise rotation, the object rotates around a fixed point in the counterclockwise counterclockwise direction, change its orientation. Coming to the clockwise rotation, the objects rotate around a fixed point in a clockwise direction, further altering its orientation. And let us discuss about scaling. There are three types: initial size, uniform scaling, non-uniform scaling. And coming to the initial size, the objects start at a specific size on the 2D plane. And let us discuss about uniform scaling. The object is scaled proportionally in both x and y dimensions, maintaining its aspect ratio. And coming to the non-uniform scaling, the object is scaled differently in the x and y dimensions, changing its aspect ratio, distortion its shape. And let us see some 3D transformations. Translation, rotation, scaling. Coming to the translation, 3D translation allow you to move object along x and y and z axes, positioning it within the 3D plane. This is a crucial for creating depth and arranging elements in 3D scene. And let us discuss about rotation. 3D rotation enable you to spin an object around any three axes, providing more control over the object oriented and creating dynamic effects. And coming to the scaling, 3D scaling gives you the ability to resize an object in all three dimensions, allowing you to recreate the illusion of depth and adjust the relative size of elements within the 3D scenes. Let us see about the 3D translation. We have initial position. The object starts at a specific position within the 3D plane. Movement along the x-axis. The object moves along the x-axis, changing its horizontal position while maintaining its vertical and depth coordinates. A momentum of along the y-axis. The object moves along the y-axis, changing its vertical position while maintaining its horizontal and depth coordinates. And coming to the movement along the z-axis. The object moves along the z-axis, changing its depth position while maintaining its horizontal and vertical coordinates as a constant. Now let us see 3D rotation. In this we have four categories. First one is initial orientation. The object starts in a specific orientation aligned within the 3D coordinate system. And let us see a rotation around x-axis. The object rotates around the x-axis, changing its pitch and creating a tilting effect. Tilting effect. Rotating around y-axis. The object rotates around y-axis, changing its changing its pitch and creating a planning and turning effect. And let us see about rotating around z-axis. The object rotates around z-axis, changing its role and creating a spin or a spinning effect. And let us see about 3D scaling. In this first, let us discuss about initial size. The objects start at a specific size within the 3D space. And let us discuss about uniform scaling. The object is scaled proportionally in all three dimensions, maintaining its original shape and aspect ratio. And non-uniform scaling. The object is scaled differently in X, Y, and Z dimensions, changing its overall size and the position. Let us see some practical applications. Yeah, here we are going to discuss about four applications like animation, game development, visual effect, computer aided design. And let us discuss about first animation. Transformations are the foundation of computer animation, allowing animators to move, rotate, and scale objects to create dynamic and lifelike scenes. And let us see about game development. Transformations are essential for creating interactive 3D environments and characters in video games, enabling the developers to control the position, orientation, and size of the game objects. And let us see some visual effects. Transformations are used extensively in visual effects like films, televisions, allowing the artist to manipulate and animate the elements to create stunning visual sequences. And coming to the computer aided design, transformations are crucial in CAD software, enabling the designers to precisely position, rotate the development process. Thank you.